Data Privacy Notice. De La Salle College of St. Benilde, or DLSCSB, respects your right to privacy and is committed to protect the confidentiality of your personal information, thus has adapted necessary organizational, technical, and physical measures to secure it. DLSCSB is bound to comply with the Data Privacy Act of 2012, or RA 10173, its implementing rules and regulations, and relevant issuances of the National Privacy Commission. By participating in this video meeting, conference, or webinar, you are consenting to our collection and use of information, including recording, in accordance with this privacy notice. Information is also processed via video conferencing platform Zoom. Please refer to their privacy policy at the website. The information processed, such as name, email address, your image, video, and audio, will be used for attendance, documentation, communication, and systems administration purposes by authorized individuals of department, office, or unit organizing the event, and other offices authorized to have access. We also use the information gathered from you for abuse prevention and privacy protection. DLSCSB shall only retain the said personal information until it serves its purpose, after which it shall be securely disposed of. Queries and complaints can be directed to the Data Protection Officer via email at dpo@benilde.edu.ph.
Let us pray. Let us all remember that we are in the holy presence of the Lord. In the name of Father, Son, Holy Spirit. Amen. Dear Lord, thank you sa gathering na ito, and thank you sa gifts kahit pandemic ngayon. And please guide us in whatever knowledge that we will be acquiring today. And may you help us to be more efficient worker. And may you widen our patience and our understanding sa trabaho namin every day. So together, our Lasallian prayer, I will continue, oh my God, to do all my actions for the love of you. Our Lady of the Star, pray for us. Saint John Baptist de La Salle, pray for us. Saint Benilde Romanson, pray for us. Leave Jesus in our hearts forever. Yon. Good afternoon. Good afternoon. We are currently in the final leg. No, final na tayo ng BR webinar and workshop. So it's a 4 out of 4 na tayo. No, hopefully magkaroon pa ng maraming webinar ngayon in the next future sa first term. And in this final leg, ito yung 4-hour to. Okay, so this is a 4-hour workshop, kaya lang pinaghiwalay namin nila Sir Lyle. No, so itong 2 hour na to, this is for this session, July 22, and the next 2-hour session is on July 29. This is itong workshop na to para sa mga students, faculties having hard time sa mga kanilang parametric skills, mga ganyan, no? Particular na lalo na sa Grasshopper. Now, this webinar is also done, of course, for our development and para maiwasan din yung pag-binge watch ng Netflix sa mga Korean novela na yan, which is, of course, I'm guilty of that. Okay. Our speaker for today is a principal architect of Block 44 Incorporated sa Manila with diverse experience in HFS Builder Incorporated, IDEA Philippines Incorporated, and may experience din siya sa kay Villegas Rojas Consultants. Currently taking up his masters in IAEC, Barcelona, Spain. Hindi natin alam, mamaya baka tapos na rin si Sir, no? Finished his diploma in BS Architecture at UST Manila, dun sa Espanya, sa eskwelahan somewhere doon. may no? Graduate din kami dyan. Okay. He reigned first place in his architectural board exam. Pero syempre, hindi ko na sasabihin yung year kasi for his protection, no? Also a licensed master plumber. Okay, so won second place in Goethe Institute and Sofa Designers United Co-Work Design Competition Okay. Now, he has won a lot of competition during his tertiary years. Okay, and very active and very charming architect Lyle La Madrid.
So
Hello po.
today, good afternoon, we will be discussing a two-part series na Rhino Grasshopper computational design. Mostly it's on Grasshopper, using Rhino as yung main software. Before kasi Rhino and Grasshopper magkaiwalay sila. Rhino as the 3D modeling software, and Grasshopper as the visual scripting software. Plug-in lang siya before ng Rhino. But with Rhino 6 and 7, kasama na siya, built-in na siya sa Rhino. So what we'll be discussing today is mostly about computational design and the concepts behind computational design. What you can do with the different types of computational design. And next week, for the second part of this series, is a workshop, a primer on Grasshopper. Yung primer on Grasshopper is basically what we thought also during our emerge classes. So basic lang siya, but what I thought there is yung basic and how to go around and try to learn more through self-exploration ng Grasshopper, because visual scripting in Grasshopper is a bit has a high learning curve, but then since it's a problem-solving software, medyo mahirap to teach all of it in one go. So what I thought there, and we will be discussing next week, is how to problem solve on your own and which resources will be needed for your own solutions. Okay, so this is computational design by me, architect Lyle La Madrid. This is for the two-part web series of BenArt and SDA. So let's first define the two terms, computational design. What is design? Design, according to Google, is an arrangement of lines and shapes created to form a pattern or decoration. So you arrange certain things to become a design. In this case, a drawing can be an arrangement of lines to create art or anything that would represent something else. Another definition is a plan or drawing produced to show the look and function of workings of a building, garment, and other object before it is built. But let's focus more on this, an arrangement. Next, what is computation? Computation is the action of mathematical calculation. Or in this day, it's the use of computers, especially as a subject of research or study. Computation is using math to rationalize a certain thing. Computational design is using math to rationalize a design. Computational design is a design method that uses a combination of algorithms and parameters to solve design problems in advanced computer processing. So every step of a designer's process is translated into coded computer language. So this is the most important thing. Every step of a designer's process is translated into coded computer language. Computational design can be subdivided into other computational design parts: parametric design, generative design, and performance-driven design. We will discuss the definitions of each. But what is computation? What is computational design? It is not magic. It is not a computer software wherein you have you will input something and then lalabas na maganda siya, or it's something na amazing or awesome. Yun kasi parang connotation with computational design or parametric design. Yung fanciful architecture, very complicated. But computational is not that. It's not magic. It is still based on you as a designer, your imagination, your process set into an instruction. Computational design is an instruction-based design. What do I mean by that? This is algorithmic modeling. Algorithmic modeling, from the term algorithm, it is about instructions. So you have a set of instructions that then produce a certain design. So if you look at this is the script for the Morpheus Hotel by Zaha Hadid. Hindi siya parang dinesign lang basta on a 3D modeling software. There are certain parameters that were given and certain instructions that they follow to produce a certain design. When you read this, it is from left to right. It's like reading a text. So as one component translates a parameter or a line or a drawing, it then passes on the translated information to another component. So those translations then create this. So it is you as a designer, as a computational designer. You're still a designer, but this time instead of just modeling in 3D, you are designing the process itself. How would information be converted and translated into better and more informed data? So the kinds of computational design are as follows. Number one is parametric design. Parametric design is an interactive design process that uses a set of rules and input parameters to control a design model. So in this case, as you can see, this is the visual script or in Grasshopper, and this is the design. The design now can be modeled and edited through the use of these parameters. These parameters now represent a specific value that is innate or specific to the design itself. So in this case, maybe this one is the center point. This one can be the radius of the polygon, the length of the polygon, the height of this cylinder, if I may call it that. And then these are the other divisions, maybe. So, kunwari ito, these has 8 divisions. Pwede siyang gawing 4, pwede siyang gawing 5. Yung height, pwedeng palitan. So, those are the parameters that are project-specific. The parameters are project-specific values that define the design model, like dimensions, angles, and weight. So, what you're designing basically is this script, this set of instruction that then produce this drawing. You are now able, since you have designed the script, you are now able to tinker with all of these parameters to create unique designs. This is a project in collaboration with Sangay Architects. If you know Sangay Architects, they are working with bamboo. The problem with modeling 3D, the problem with 3D modeling bamboo structures is it's very cumbersome and RAM intensive. So what happens is if you model a bamboo pole, maraming ano yan, especially in SketchUp or maybe in other 3D modeling software, maraming lines yun eh. Because SketchUp, for example, doesn't recognize curves. So puro yan straight lines. To mimic a curve, gumagawa siya ng polygon. So for example, a 20-side polygon would represent a circle. So what happens is you will extrude that circle and create a pole that would then represent yung bamboo. So imagine how much lines are there in one model. So what happens is sobrang bigat ng model. And if you need to change a certain parameter, for example, in this case, kailangan mong i-move yung point na to pataas to make it more pointy, or move mo siya pa dito para mas mag-flatten ng konti. What happens is you're only moving a certain point, not the whole model. You can also do that naman with Rhino. So you can use a NURBS curve so that that point would then be represented by a curve. And when you move the curve, magfa-flatten siya, susunod yung curve. But the problem with that is kapag nausog yung isang pole, kapag nausog yung isang line, the only thing that moves is the line. Yung mga pole hindi. So kailangan mo silang isunod, right? So isa-isa mo silang susunod. So imagine this is a small project. Yung susunod medyo malaki. Imagine the amount of time
used just to move all of those poles to the correct position. And yung pag-move na yon is not actually based on anything. It be based on tansya, if it would look good or not. But as you can see with this one, parang equal sila, di ba? So with Grasshopper or with visual scripting, computational design, it's much easier to control where the points are and how those points will then be translated. So in this case, what we did is we have a line, the profile of the roof. So tatlo yan. 1, 2, itong roof ridge, then 3, itong baba. And we divided them into sections. So for example, itong section na to, these are the sections that would go on top of the columns. And then ito is yung mga freestanding na sections. So wala silang lines. So ang reference nito is yung building. And they are divided equally via script. And then those points now are directly over the columns. It was zoom to. Anyway, so if you zoom in here, you have 3 column-like supports that support the edge of the roof frame and goes to the column and beam here. So dito, you can also program this with how much or how many points ito, how many points here would this point hold. So in this case, 4. It's holding, 3. It's holding 3. So 3 dito, 3 dito, and then dito 2 na lang kasi wala na yung last there. So that can be coded also. If I change it into 4, automatically kukuha siya ng 4. So that's how easy it is to control a parametric model. Because the model is based on the parameters. The parameters are following certain instructions. So if you change the parameter, it will change through the instruction and change the model itself. So this is a more complicated one. This is another project in collaboration with Sangay Architects. Dito, they already have a frame. But what happens is, when you show the structural engineer a model or a design, kailangan mo lang is one line drawing. So they would extract one line that would represent a group of bamboo. So in designing bamboo structures, para palakihin mo or patibayin mo yung member, what you're gonna do is to have more poles. So in this case, there are members na 4 poles, there are members na 2 poles, there are members na isa lang. So with traditional 3D modeling, imagine a certain point. Imagine one point. So this is a line. Kailangan gumawa ng 4 poles. Now, those 4 poles now should follow this point because this is the point of reference, right? So if you move this sa traditional 3D model, move mo to, i-move mo sila lahat. Isa-isa or as a group. But then what happens is may kadikit to sa dulo, di ba? May kadikit siya dyan. So what happens is you have to move this as well, or else it will move everything all at once. And instead of this point and this point is aligned, may access yan. Mangyayari is, kunwari ito, minove natin papunta doon. Ganito pa rin yung angle niya, which is mali na kasi pag ganun na yung angle niya eh. Because it's not based on a certain instruction. So yun yung parang pain point that we're trying to solve. That's one pain point that we're trying to solve in their design process. And one solution is to use Grasshopper so that when we change a number of poles or when we move this point, all of the 4 poles would move. Kung dito kayo move yung point na to, lahat yung 4 poles na yun would move together in unison. And it is proportional and correct in the design itself. Also, we can also define how many poles are there. So kung yung point na yon holds 4 poles, 4 yung lalagay niya. But if you change a certain parameter, you can put 2 poles. Or siya mismo holds 1 pole. So that's a lot easier. Kung titingnan mo, dito yun eh. Pwedeng dito is nakalagay, so this is the number of poles. So dito pwedeng 1, 2, 3, 4, 5. So you just move the slider and together, magmo-move din kung ilan kailangan mong pole. So that's the beauty of parametric design. It's an easier way of designing, but easy in a sense na pagtapos mo na yung script. During the process, you are designing the script. How the script would think, how the script would manipulate data, and how that data will be translated. But after that, after you have designed that, you have the free will to redesign your project based on that certain script. And that instruction is project specific. So in this case, we were able to design this and change the number of poles. We will be able to change the number where those poles are located, and hindi na kailangan i-model lahat. Also, we can also define kung ilan yung mga members. So in this case, pwede natin siyang i-divide into 10. Or pwede rin siyang i-divide into 4 lang. So instead of this having 10 members, pwedeng 3 lang siya. So it depends on the parameter. But still, you're just moving sliders there. You're not anymore modeling manually. So you're modeling parametrically, which is an easier way of modeling complex geometries. So that's why ang connotation of parametric design is complex geometries, because it is so difficult to 3D model complex geometries. But it's easier to 3D model complex geometries through parametric design or parametric modeling. Another branch of computational design is generative design. So imagine yung mga parameters na to. You have millions, if not thousands, if not millions na different designs because of those parameters. So in generative design, what we're doing is to create iterations of that certain algorithm or that certain script. But we would have a requirement, a design requirement. So for example, we are doing performance-based modeling. Ang mangyayari nun is, there's a certain parameter wherein yun yung favorable for us. And using iterative design or generative design, we will generate all of the possible iterations and choose which ones will be the best for our design. So in definition, generative design is an iterative design process that user-defined inputs to produce multiple design concepts that meet specific goals. So the inputs are rules and parameters that define design requirements, which is similar to parametric design, because this is parametric design. The difference is we're automating the generative process. So with the generative process, with generative design, the user also inputs success metrics that will evaluate the results. So these success metrics will define kung ano yung gusto nating makita sa design. I will show you examples later. Performance-driven architectural design. This one naman emphasizes on integrating an integrated and comprehensive optimization of various quantifiable performances of a building. Medyo wordy, but siguro this would help you out. So you have an input and you have an output. Input can be environmental data, climatic data, or daylight, or whatever. You have also your building, or kung ano yung i-simulate or i-analyze. So what happens is, first we input the parameters. Number 1, climate data, geometry, which is ito, schedules and loads, louvers, blades, definition. Ito is yung design ng facade. reverse blade definition. Step 2 is to do performance simulations. So with this design, for example, ginalaw mo na yung parameters mo. Balik tayo dito. Ginalaw mo na yung parameters mo here. So meron ka ng design. Ito. Right? Then you will now test that design if it performs well. So we'll do daylight analysis, radiance parameters, and you will have an output, which is this. Based on this, you would now assess if you are okay with the values na output na analysis. If not, you have to change the design. So you will move again the sliders and you choose which one is the best, which one produces the best output. And after that, there would be energy simulation. So in this project, there will be energy simulations and optimization. So optimization process, you can use generative design again. How? You will now tinker with all of the parameters here using generative, the design process, and it will generate all of the iterations possible using all of these parameters. But since meron kang metrics, performance metrics, pipiliin mo lang aling output ang gusto mo makuha. Because there will be output na sobrang dark nito, there will be output na sobrang bright. But then you would then put what kind of parameter would you want to see? And dito lalabas yun. So you are now collecting the best output out of all the iterations possible. So that's performance-driven design through generative design models. This is another thing. An example of performance-driven design is you're using sun path analysis and solar radiation to now determine what kind of facade would help you reduce your solar radiation. Or if you're using solar panels, you can now use the sun path analysis to know what is the best orientation for your solar panels. So in performance-driven design, these are the processes. Number 1, information gathering. Number 2, digital design models. So you have the design concept, and you have the simulations, and then parametric form finding. These are the different softwares that you can use. So in design concept, we have Rhino, Revit, 3D Max, Maya. But for computational design or parametric design, better ang Rhino and Revit. Kaso, meron silang specific na visual scripting software also. So sa Revit, it's Dynamo, and sa Rhino, it's Grasshopper. The thing with Rhino Grasshopper, kaya siya more ubiquitous, is because Grasshopper is open source, and you can have a lot of resources online, and you can check a lot of forums wherein most of the problems, or meron kayong problem, there are similar problems out there that have already been solved. So you just look through the website of Grasshopper and the forum. Simulations, you have Ecotech, Vasari, and custom spreadsheets using Python, siguro. And lastly, sa parametric form finding, you have Grasshopper, Maya scripts. In this case, it's a Perkins and Will custom Revit plugin. Wala dito yung Dynamo. Next is digital fabrication models. Since these are very complex designs, there is a gap between the design process, which is very digital, and the fabrication or construction process, which is very analog and manual, especially here in the Philippines. Right. So later on, I will show you projects that show yung dilemma na yun. But in this case, since they have the technology, it's easier to produce a lot of unique, a lot of different iterations. For example, itong facade nila, ganito siya eh. So one design, meron multiple designs of this, multiple iterations of this design. So let's say you have 500 different iterations of this design. Iba-iba lang location ng butas. It's difficult for a person or it would take a lot of manpower, man hours, to produce yung unique design pieces na yun. Because you have to measure all of those eh. And the differences between them are very minute. Minsan millimeters lang. But those millimeters would then show kung paano, how the design works actually. And mahirap yun ipakita, mahirap yun gawin manually. So what we do is to use digital fabrication techniques so that we can automatically and more precisely create these iterations. So for example, we can use 3D printing or laser cutting, CNC milling to produce these complex geometries. And lastly, yung assembly. With assembly, even if you have digitally fabricated all of your components, there's a human to put all of those there. So what you need to do is to create a set of instructions that is very specific to this construction or this project. What happens now is, for example, you have, again, 500 different pieces. Hindi mo alam paano sila i-orient, di ba? So, to actually draw those instructions manually, medyo mahirap. What if nagbago yung design? What if yung set of angles is iba-iba, very minute differences, then ikakat mo lahat yun. Mahirap. So, this is another thing that helps us, that parametric design would help us, is this, producing those working drawings. To be able to produce the drawings and instructions so that how you could be able to assemble all of these things. This is another project by IAC, the Fab Lab House. They used performance-driven design also and used the sun path to determine what is the best and optimal location of the solar panels. Sa Pilipinas, ganito kasi. Kung saan yung araw, where it rises and where it sets, dun tayo. I-orient lang natin siya doon. Or, ito, if hindi pwede, we will fabricate a very linear assembly so that it will point directly to the sun, kung saan yung sun path. Dito, what it does is created an optimal shape wherein you would be able to capture all of the sun rays, and all of the times of the day. So dito, this was determined by a script, and ito yung lumabas na shape. Doon nilalagay solar panels. We are in the fourth industrial revolution. It's about data, data, and data. And the problem with the design and construction industry is we're lagging behind with using data as part of our design process and as part of our construction. And if we do not follow into this trend, may iwan tayo. May iwan not because nakikiuso tayo. May iwan because the pace and accuracy and precision that data would be able to give us is hindi natin makukuha. Okay, now I'll be showing you some of the examples. Some of these are works of my current students. Some of these are friends from or who are alumni of Benil, and some of them are my work. Questions? Do you have any questions so far?
Any questions, guys? Mukhang wala naman, sir.
Okay, sir. I will share next presentation. Puro to rundown of some of the projects that are related to this and local. Kasi marami na examples sa mga foreign examples. What we want is mga local projects and local context then.
Tama, sir.
Okay. This one is a thesis of an alumnus, si Noel Narciso. what he wanted to create is, yun nga, this is a performance-driven design thesis. He is designing a facade which the design follows the environmental simulations. So dito, ang brief niya, let's read the brief. With rising global temperature, buildings as the highest contributor to greenhouse gas emissions and current building method in the Philippines, there's an imperative to innovate passive design. The question is, how then can we develop an effective modeling and simulation strategy for integrated performance prediction of commercial high-rise building envelopes? So this is in relation to facades or building envelopes. Para siyang ano, computational design Bristolay. Actually, yun siya. So the Bristolays before, they're very passive in the way we have designed them. Diba? So parang maglalagay lang tayo ng mga Bristolay. Yung depth is dependent on us, on the architect, kung gaano kalalim. But not much is done when using actual data from climate data. So dito, ang pinapakita niya is you can do that and you can automate that process as well. So in his process, he has established yung model, parang yung kanina na pinakita ko. You will establish the model and you will simulate. Una, without the Bristolay. Second, what design is best fit for this simulation? So in this case, nag-design siya ng different iterations and different designs also. And by using those designs, different scripts, he simulated what would happen if you would use them. So based on his simulations, may kita mo yung mga figures. Kumari ito, this is very hot. Ito relatively okay. Mas konti yung red. And through that, he was able to create a design that is the most efficient in terms of where the building is located and kung saan siya naka-orient. So this is the design of that. By also using Grasshopper, he was able to 3D print and model accurately kung ano talaga yung nasa 3D model niya. But since those data are there already, madali na lang yung process na yun. So you can see the bends of the facade. You can see the bends. This will be difficult for a normal worker to replicate. I said this is accurate to the data. So any deviation from this design, may deviation din dun sa result. Na ito kasi yung result na gusto niya, diba? So kapag binago mo yung shape na yun, magbabago din to. But then we don't want that because we have already chosen a certain design. So the best fabrication technique is to use a direct digital fabrication technique. Direct meaning from digital design to digital fabrication. Okay, another project is also from Roel. This is a collaboration with In a Half Studio, a pocket park. So this one, it's fairly simple. You have all of these parameters and you have this line that would represent where the people or the pathway. And the pathway now creates a void. So meron siyang mga shapes here, mga boxes there that would determine where the planters are. So ito siya. Then yung path is yung parang then yung path yung pinaka that would determine where the voids would be. Okay, these parameters he will be able to edit, for example, kung gaano ka wide yung mga path na to, or gaano kalalim, or gaano kalayo from these trees. So it's easier for him to design that. Yeah. Some renders. Okay, this is from Emerge. I think this is emerge 2. Yeah. Dito naman he used, but it's not shown here. Zhao and Francis, they used computational fluid dynamics to design an aero block that would passively cool an area. So these are the iterations. Hindi nila pinakita dito yung actual CFD testing. CFD is computational fluid dynamics. But they have come up with they were able to determine which one of these design is best for what they want using computational fluid dynamics. Makikita mo dun sa simulation nila kung alin yung parang nagko-cool ng room the most. This is from Emerge 2 also. This one, they're designing a palenque with a food digester as their source of energy. What we wanted to do is to create first the parameters that would determine the volume and the number of digesters and the amount of energy produced per ito yung mga computation nila. So all of these are translated into parameters. This would determine the size and shape of the design. So these are the renders. So the parameters here script. So the parameters here are number 1, yung population, and then yung digester ratio, area per digester. So these are the formulas they used. So food waste density per day, digester volume, volume per digester. There's a formula behind that. And also yung sizes ng stalls, yung height ng stalls, and how would these roof be oriented also. Yeah. Next is Hakbang. This is a conceptual algorithmic design on integrating active play and circulation in kindergarten schools. This is a more planning approach or a parametric approach in planning design. So they research different simulation and algorithmic planning techniques. And the most important thing here is you cannot create a script without you knowing how to model a design. What I mean by that is if you cannot model it by yourself, you won't be able to do the script. That's because you are designing the model as you are designing the script. The script will help you automate certain things, but it will not design for you. So in this case, what we do, if you're going the path of parametric designs emerge, what we do is to break down the design process and put them into individual instructions. So in this case, input lot coordinates, and then setback, and then building space, and then orientation. So from those, you will be able to create number 1, building space. The spaces are defined by input of students, input of class capacity, and then the spaces also have adjacencies, which is then oriented through different orientations based on the lot. And then you can create the number of floors, floor priorities, etc. And that would then create yung pinaka process, at least conceptual process on how to design this structure. Now, if you have this conceptual process, you will now be able to create the script itself. If wala ka nito, mahirapan ka mag-design. Why? because you are designing the script. Yung script kasi it's just visual scripting. It's just coding the instructions that you already know. This is their process showing you different tabulations and different parameters that would help them determine your adjacencies and sizes. Ito yung script nila, the code for the setup pa lang. Yan. If I may show you again the slide of the Morpheus building. Right. This one is a personal project of mine. The difficulty with designing digitally is you cannot, especially with our technology here, you cannot always do digital fabrication. So the problem is the manual translation of digital design, especially with design as that needs to be accurate and precise, like this simple facade. It's simple when you design it. It's simple when you model it. But in actual, it is very difficult for you to fabricate these kinds of designs with what we have here in the Philippines. So what happened was initially, when we did this, ano lang siya? So it's a grasshopper script. It's a simple grasshopper script. Hindi ko nata nilagay dito. Yeah, it's a simple grasshopper script. It's just a curved subdivision, and then you're connecting all of those lines from those subdivisions. And yung curve is dependent on you, kung anong gusto mong design. That's it. It's a short script. But then, what happened is, nung pinakita mo yung designs with them, ang una kong gagawin sana is ilagay dyan yung mga angles and yung lengths of those lines. But what happened was, hindi siya as smooth as how it looks right now. Kasi there are deviations, minute deviations, imperfections of manual craftsmanship that shows it shows when you zoom in. Hindi na to pinalitan na kasi yun. So you have to be precise in how you present your working drawings. So the challenge here is how will you be able to translate a digital design into a more legible working drawings for laborers and skilled workers. So what they did is to create yung point system where they would just draw points, tapos they would connect those points to create a panel. So yung mga panels na to are in order. We have 123 pieces of unique, 65 unique pieces, 123 pieces all in all. And only 2 out of the 123 pieces were misaligned. And yung misaligned na yon, hindi na siya masyadong halata, unlike yung unang iteration. So we used Grasshopper to extract all of those points. Mahirap kasi if extract mo to isa-isa and you draw them one by one. Dun pa lang magkakamali ka na. So what we did is to automatically extract all of those points. Yes, so this is the script pala of the Morpheus building ni Zaha Hadid. Ito. So this is just one. This is just one part of that exoskeleton. Another example is, and last, performance-driven design. This is a sneak peek of what Xavier Tixon, also an alumnus of Benilde, is doing for Arcadis. This is on a corporate level. So they have climate visualization, solar heat analysis, wind and CFD analysis, and the luminance. And these are the plugins that they've used. So basically Rhino Grasshopper, and these are the plugins they use. Ito basically yung sa taas at tier 2, these are the climate models. And then dito sa baba, it's more of for the 3D modeling naman. So these are plugins for 3D modeling. This is for the climate data and manipulation of the climate data. So they do, so these are the Ladybug tools, and then climate analysis. So this is an introduction to climate analysis using Ladybug. Picture visualization. And they're doing this here. Their office is in Makati. They will share. Solar radiation. So this would just then inform them, or the architects, of how the buildings would perform during certain times of day, certain days of the year. And they will now be able to make tweaks and tweaks in the design that would affect the performance of the structure. So if we look at this, meron dito 510 kilowatt hour per square meter. So this is a bit high. What they can do is either they can create or design a facade for that would lessen yung heat gain, or they can redesign structures around it that would help out. Tulad nito, meron siyang roof above it that would help out reduce now yung heat gain there.
Sir,
Yes.
I don't think it's shared the screen.
Oh. Okay, sorry. Ulitin natin. So this presentation is sent to me by Xavier Tixon. What we wanted to show you here is the performance-driven design. This is on a corporate level, so this is for Arcadis. They used Grasshopper and Rhino and Grasshopper and yung plugins behind it to do climate visualization, solar heat analysis, wind CFD analysis, and illuminance analysis. So these are, he divided into 3 tiers. Tier 1 and 2 is yung Rhino and Grasshopper. Tier 2 is yung climate analysis tools. And this is the extraction of climate data. As tier 3, this is more of for the 3D modeling. So we have Launchbox, Weaverbird, Elephant, Pufferfish, etc. These are the tools within Ladybug that would help you get certain data and use those data for your simulations. So climate analysis, etc. So for example, in this case, meron dito is 510 kilowatt hour per square meter. So this has a high heat gain or radiation. Ang pwede nilang gawin, since nakita nila yon, pwede nilang i-design ng a facade that would help out reduce the heat gain, or a roof, or design the structure in front of it that would help alleviate the heat gain, etc. But without this, you won't be able to do those kinds of intervention because you wouldn't know that information exists. So with this, we're analyzing data, we are able to see that. Command is north wind analysis. Is more of wind analysis. Yeah. So you can see the areas wherein there's high velocity and kung saan yung nagdi-dissipate yung speed. Within the corners, ganyan, within yung mga escanitas. Yeah. And yung illuminance, how much light is going into the structure. And with this, you will now be able to address which areas are dark, which areas are light, which areas would be needing intervention to add more skylights, saan sobra, and if you wouldn't want that, this would help you out with that. Yeah. Okay, so those are the examples. Next week, what we will do is we will try to explore, and I want you to, yung mga nandito and would be attending next week. I want you to download una, so Rhino Grasshopper. Next is you download this, the Grasshopper Primer. This is by ModeLab. This is the, what I can say is easiest to understand na guide on Grasshopper that is free out there. So this can be downloaded. I can send this over to Sir Ven also, so he can distribute it to you. But this is free. You have all of the different components, and they will explain everything. And we will go through some of this next week. Yeah. So there's introduction of what is Grasshopper, how to use it, yung UI. Yeah. So all of these things we will discuss next week. That's it. Do you have any questions, guys?
I-email mo sa akin yan, sir, no? Sige.
Yes,
No
sir.
problem.
I-forward
Thank
ko
you.
sa inyo, sir, so that kung hindi nila mahanap
Okay,
online,
okay.
mag-distribute natin. But it's
So,
online. Grasshopper
okay.
Primer.
Sige,
Yes, sir.
sir. By next week, they will be needing a computer. Tama ba, sir?
Yes, sir.
A PC. Okay.
So parang introduction and workshop no
Yun next week,
Grasshopper
no? Okay, okay.
as yung ModeLab as the guide, yung Grasshopper Primer. So they can ask me questions.
Yun po, mga guys. So, any question? Baka yung iba kasi nag-prepare na ng laptop, no? So, next week po, ang ano natin, 29. Yun ang war time natin sa no? Sa Grasshopper. Thank you, Architect Lyle, for a wonderful talk. So, may mga tanong pa po ba?
Yeah, if you have any questions, help with your projects.
Ayan, si Sir Alberto Jose Marie.
Hello po, sir. Meron po bang courses na magturo ng Rhino sa video?
Courses?
Yes,
Sir, currently kasi we're thinking of updating right now. Kasi nga, ang last na software study nyo is Revit, which is ARCAD 2, no? Tapos yung ARCAD 1 is a BASICAD. The very least is yung sa Emerge 1, Sir Lyle, no? On hand na rin kayo sa Rhino that time, no? So that's sa specs po, sa Emerge 1 po. Yun po ang merong Rhino. Yun, sabi ni Sir Tixon. There are no official certified courses in PH now by McNeil, but maybe in the future. Tama.
But if you're familiar with AutoCAD, or if you're familiar with 3ds Max, it's relatively easy for you to understand Rhino. It's not much different than CAD and 3ds Max.
Ayun, pwede pala ako mag-Rhino. Kita niyo yan.
Yes, sir.
Madali yan. Kasi I bet lalo na sa generation nila, no, ano na sila click in, ano na lang sila nakakapag-intuitive na sa kanila yung mga UI no? You can do it, of course. Magugulat kayo, yung mga anak ko nga, nag-i-scripting na may subject ang mga bata na scripting and coding.
Grade school, di ba?
Grade school, sir. Ano yan? Ewan ko, nasa private schools yung mga yan ginagawa nilang summer classes yung coding at saka scripting.
Yes, sir. No, but kasi, parang isa din siya talagang skill necessary in this day and age is yung coding. But what Grasshopper did is to make it more visual. Kasi ginagawa na naman na yung pag-coding in architecture before. But the thing is, literal coding siya. So nagta-type ka and you're typing commands, ganyan, with Python, C++. But mas mahirap kasi yan for, parang nung ginawa siyang visual scripting, mas naintindihan especially ng mga architects, ng mga designers. Mas maging madali for them to do these kinds of things.
Yes. Sabi nga naman ni Xavier Tixon, but actually everything can be learned on YouTube and internet for free. May mga ganyan na rin for free.
Yes, sir. Yung sa emerge naman, sir, it's more of introduction of different emergent tools. Sa Rhino and sa Grasshopper, even yung mga pinakita ko kanina, yung ibang ginagawa nila dun is hindi ko talaga tinuro. It's more of them exploring yung anong seed na binigay natin sa kanila. So, ang unang tuturo natin is more of like yung tuturo natin next week of how to navigate Grasshopper. And then later on is what are the resources available na pwede nating ibigay ngayon so that they can explore more. Visual scripting kasi it's very project specific eh. Kung makikita nyo sa kanina sa mga examples kanina, no two scripts are the same even if they're from the same project. And also, kunwari nagbigay ka ng isang problem. Let's say you will design a skyscraper na ito yung parameters nila. Yung dalawang magibang tao, magkaiba din yung way nila of how to do that script. Kasi in a way, again, your script reflects how you design. And how you design is a reflection of you. So kung paano yung ano siya, di ba? Algorithm. So instructions. Kung paano mo design yung instructions mo, ganun din. Kahit same kayo ng output, magkakaiba yun. So mahirap na ituro siya na ito lang, ganito mo siya gawin. It's more of what we will teach them is how to navigate that kind of environment.
Ganun pala yun. Tama, oo nga, no? Parang sa sculpture, walang iisang sculpt. Iba-ibang artist eh. No? Tama nga. So, any questions pa po? Before maybe we can end this, then tawid na tayo sa July 29. Mag-mass fast forward. Pwede ba fast forward? Tulog lang tapos 29 na.
Sir, I missed the first 30 minutes of the webinar. But I have a question regarding the environmental data for simulations. Is it gathered from Grasshoppers and the program? Hindi siya. It's available online, but ang tawag doon is yung EPW or the EPW weather data. So, in-extract lang yan from the web.
I-extract lang pala yun.
Pero yeah, hindi pala siya direct message ko siya. Sorry. In-extract siya, but using these plugins also. Parang nire-read lang niya online kung alin yung nakalagay doon. Tapos, yun yung gagamitin ng data.
Pero free naman yun, sir, yung pag-extract.
Free naman lahat.
That's nice. Okay, may mga questions pa po?
Next, wala na.
Ay, merong nag-raise ng hand.
Yes.
Sino yun? Sir Alberto, yes.
What version po now, Rhino, do we need?
What Rhino do you need?
What version po?
Yung latest na makuha niya, okay. Even Rhino 5 is okay. But the latest version is 7.
So it's 5 or 7? Pwede po.
5, 6, 7.
Yun, pwede. 5, 6, 7. Okay, so siguro sir, that's it for our day 1 of our first leg ng Rhino Grasshopper workshop. We will be expecting yung mga laptops ninyo next time. So good luck and see you again on July 29. Okay, tama po.
Thank you, sir.
So, thank you po. Thank you and bye-bye guys. See you next week again.
Thank you, sir.
Sige po,
Thank you.
sir.
Thank you, sir.
Thank
Yes, sir.
you. Thank you for the hearts and